Hi, it's Hayden Thompson again, and today we're going to be talking about our new project, which is funded by GRDC, which is called Nitrogen Banking Strategies. So for this project we have 4 different trials, and today we're going to be talking about the one here, which is at Harden. So we also have a site back at Temora. We have a site at Condobolin, which has been run by Central West Farming Systems, and a site south of Wagga, which is being run by Riverine Plains. So this trial, it's all about how we work out the nitrogen application for a crop. So a lot of research recently has shown that still the biggest thing causing yield gap in especially wheat is nitrogen. So we have our water limited yield potential, and the main reason we're not meeting that is nitrogen. So if nitrogen is the main reason we're not meeting our yield potential, why don't we put more on? So we've believed in the past that we're risk of losing, if we put too much N on, we're risk of losing it from volatilisation, denitrification, even nitrate leaching. And there's also the profitability. So we might, especially at the moment when urea is really highly priced, if we're putting too much on, we might not be making a profit out of what we're growing. So those are the reasons why we don't put a lot of nitrogen on sometimes. But this trial is what if we did. So we've used a few different methods of calculating our N rates, and that's what our different treatments are in this trial. So we actually haven't put the urea on yet. We'll talk about the treatments and how we've calculated them, but today is actually the day that we're going to top dress this trial with urea and apply the different rates of nitrogen. So as I said, all the different treatments in this trial are different strategies of calculating the N rate. And so to start with, we have our baseline treatments, which is a Neal control, and what we've called the national average. So that's what we believe to be about 100 kilos of urea or 45 kilos of nitrogen. And so that's what we use as a baseline in this trial. So this is our first strategy, which is using decile rainfall. So you'd be familiar with this method. It's what's used in the farming systems trials, where they compare a decile 2 to a decile 7 right through their trial. So how it's done is that it's using yield profit, which is based on APSIM modelling. And what we do is if we say either this is a decile 7, for example, if we have a decile 7 rainfall from this point on, what is our yield potential going to be? So the modelling calculates that, and then we put on enough urea to meet that yield potential. So in this trial we have right from decile 1, which is still a very conservative amount of urea, right through to decile 7 and 8. So there's quite a few different treatments there, and they all have a different yield potential target, and then we apply enough nitrogen to try and meet those targets. So in the farming systems trial, where they're comparing a decile 2 and a decile 7 nitrogen strategy, even through the very dry years of 18 and 19, they found that applying that extra nitrogen was really beneficial long term. There's a legacy benefit from having that high-end strategy. So in multiple years of cropping rotations, having that high decile 7 nitrogen strategy was very beneficial. So another strategy that we're using is N banking targets. So what that means is it's a lot simpler method. We're just looking at soil mineral N, and we're setting a target of soil mineral N that we want to reach. So how do we calculate that? Well, we're just simply taking soil tests, we're knowing what's there already, and then we're setting a target. So the target is what we think the soil can hold based on the physical properties of the soil, as well as the annual average rainfall that we have here. So we're not thinking about the crop that we're growing, we're just focusing on reaching a soil mineral N target. So we have 3 different levels that we've put on, different N bank targets. We have what we call our profit optimal, and then we have a yield optimal, which is just 25 kilos extra, and then we have another one which is 25 kilos below what we think the optimum might be. So these rates are probably way more than this crop needs in this season, but we're not worrying about that because we think the nitrogen will still be there once the crop's taken what it needs. So we've just put on enough to meet our soil mineral N target, and then we can test to see if it's still there later. So the last thing we're looking at in this trial is something that we don't want to forget about when we're thinking about nitrogen, is how important legumes are. So this treatment is a straight vetch, which is part of some treatments that are rotation treatments. So this year it's just a brown manure crop, so it won't be harvested, but we can see the legacy of the N that the legume is putting back into the soil. So very important because it's a much cheaper form of nitrogen and it's going to drive the whole system when we think about the legacy effect of a vetch brown manure crop. So that's why we've included that in this trial too, just to make sure we know that how important legumes are. So in all 4 trial sites, we'll be taking biomass and harvest index cuts, and then we'll measure the grain yield on each plot. But then most importantly, we'll do some follow-up soil testing. So that soil testing will be able to tell us how much N is left after we've put on the different rates of nitrogen, and then we've grown the grain crop as well. So we'll be able to see what's left and see how effective our treatments are, and if we've lost any other N through other different loss pathways. So thanks to the GRDC for funding this project, and hopefully over multiple years we'll have some really interesting results to share with you.